Another type of dispersed air flotation unit are the pneumatic cells. Pneumatic cells depend upon compressed air for agitation. It gives a relatively mild agitation, producing a clean froth relatively free from gangue. In general, about 50% longer contact time is provided in pneumatic machines. There are three examples of pneumatic cells presented in brown. These are the callow cell, the callow-Macintosh cell, and the airlift cell. The callow cell is one of the oldest and simplest but is now practically obsolete. The feed enters at the high end, the tailings being removed from the other. A blanket covers the bottom of the trough. Compressed air is admitted below the blanket to each frame by pipes projecting through the solid bottom of the trough. The small bubbles of air passing upward from the blanket induce a mild agitation and become absorbed or attached to the particles to be floated. The froth, usually maintained at 8 to 10 inch, in the tank or trough overflows into the concentrate launder surrounding the cell. The air consumption averages 8 to 10 cubic feet per minute square feet at a pressure of about 4 psi until the blanket becomes blinded, when higher pressures may be needed. Callow cells have been satisfactory for many ores, especially those that are easily floated without great agitation. So the next example of pneumatic cells is the callow-Macintosh cell. The callow-Macintosh cell carries a hollow revolving rotor made from a steel tube about 9 inch in diameter and perforated with 3/4 inch holes. Canvas or perforated rubber sheet is fastened to the surface by means of steel bands. Two scraper bars made of 2-inch angle iron are bolted the full length of the rotor. This machine does not blind easily and can handle heavy slurries with a water-to-solid ratio by weight of 1:1. The quantity of the air necessary for operation varies from 4 to 8 cubic feet per minute per square feet of rotor surface at 2 to 2.5 psi. A 1/2 horsepower motor is generally capable of turning the rotor at 10 to 15 rpm. The last example of pneumatic cells is the airlift cell. Airlift cell consists of a V-bottom trough divided into sections by vertical baffles. Air is supplied from a header running the entire length of the trough to the air connections at the top of each cell. Air flows down to the bottom of the vertical air pipe within about 6 inch of the bottom. The air bubbles carry some pulp upward through the perforated apron, thereby agitating the slurry and forming froth, which is deflected by the dome against the sloping baffles. The froth overflows over the overflow lips along the sides of the trough into a launder. Another dispersed air flotation unit are the mechanical cells. So mechanical cells incorporate a mechanical agitator that draws in air and beats it into the pulp. It may give more thorough flotation and tailings more nearly free from material desired in the concentrate, but concentrates contain more gangue. At high altitudes, auxiliary air under moderate pressure is frequently supplied. It has a greater capacity for the same volume and helps condition the pulp, giving greater capacity to the conditioner. The examples of mechanical cells are the mechanically agitated machine and the Fagergren machine. The mechanically agitated machine consists of a square cross-section tank provided with an impeller which violently agitates the pulp, affecting some conditioning. The rotation of the impeller sucks air downward through a sleeve surrounding the impeller shaft and breaks it up into fine bubbles. At low pressures and elevations above 8,000 feet, adequate air is supplied only by aid of a blower. The next is the Fagergren machine. The Fagergren machine features a rotor-stator assembly for agitation and aeration of the pulp. The stator consists of cylindrical spacers mounted between two rings rigidly fastened to the tank. The pulp is drawn by the impeller blades into the rotor. Rapid pulp displacement creates a partial vacuum which causes air to enter into the rotor through the stun pipe. In passing between the cylindrical spacers of the rotor and stator, the pulp-water-air mixture is highly agitated, giving effective aeration.